Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve some questions on normal approximation to binomial distribution. And the first question we have chosen is from the paper 9709/55 for the session May June 25. And definitely we are going to solve question number 3. Okay, let's read question number 3 of this paper. In a certain large school, on average, two pupils in five have music lessons. A random sample of 80 pupils from this school is chosen. Use an approximation to find the probability that fewer than 27 pupils have music lessons. So that's all about the question. Now we are going to approximate this normal distribution to binomial distribution. Let's start our solution. We know that whenever the word approximation mentioned, it means the distribution is given in binomial, which is to be converted to normal distribution. So let us write first, it is given as binomial distribution, and we know the parameters for binomial distributions are n and p. N is the total number of experiment is 80, and p is the individual probability. What is the probability? Probability was two pupils in five. That means p equal to p is equal to 2 over 5. 2 over 5. So what is going to be the failure in each case is q is equal to 3 over 5. So if P probability of music class is 2 over 5, then probability of not having music class is 3 over 5. So our P is probability is 2 over 5, and 2 over 5 can be written as 0.4. Let us use decimal point 0.4. So this is our n, this is our p. Let me show you with different color. N, this is p. And if we convert this distribution into binomial, I mean normal distributions, for normal distribution n, x belongs to node n, x belongs to normal distributions, and the parameters for normal distributions are mean as well as variance. So mean is actually n into p. If we multiply n and p, it is mean. So 80 into 4, that is 32. 32, and the other parameter is variance. Variance is npq. So if you multiply 32 by zero point 0.6, it is going to be 19.2. So let us write 19.2. 19.2 is our variance. So this is how we should start our solution, and this is mean is np, and our variance is npq. Npq, I will have to use different ink. Then np as well as q is variance. I think you got my points. Well, now they have told us to find to approximate. So they have told us to find the approximation for fewer than 27 pupils. Okay, so let us write probability of x less than 27. So here there is a crucial point when we apply the approximation concept. Remember, it is instead of 26, I mean 27, it is going to be 26.5. Now the question is, why did we do this? It is actually continuity correction. Continuity correction means, you know, that the question is given in binomial distribution, whereas we are converting it into normal distribution. Binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. That's why from binomial to normal we will have to convert it into continuous random variable. That's why they told it's less than 27, so we will have to subtract 0.5 to make it correct in continuity. Now we are going to standardize this score. So probability of, you know how to form the z score. Z is less than x minus mu zero point 0.5, and our mu is actually mean value. Mean value is 32 over standard deviation. Standard deviation is the square root of the variance. Variance is 19.2, so it is 19.2. Well, then if we simplify this, our z score is getting less than, it must be negative because 32 is negative term is larger, so negative 1.255, 1.2 as well as 55. After that we will draw a normal graph. Okay, let us draw a normal graph. Suppose this is our normal graph, and as our standard deviation is z score is negative, suppose this is, here is our z score. Okay, z score is 1, suppose it is 1.2, 1.2. So which part is our probability? This region, this dark tiny region is our probability. Well, now, if I draw another curve, another graph, look at this. So from these one, we require that here it is 0. Since the normal function graph is symmetrical, so we can assume that, we can say that this part, this tiny part of the second diagram must be equal to the tiny part lying on the left side of standard, I mean mean value 0. Okay, so we require actually this tiny part where the z score is going to be 1.2. Now what we can do, actually we are going to use the normal distribution table. In the table, none of the probability is less than half, so always the greater probability, we can find the greater probability for corresponding z score. So what we will do, we will subtract this large part for corresponding z score. This large part we are going to subtract this red part, and surely we will get that tiny dark part. I think you got my point, that whenever the z score is negative, or our probability is tiny part, then we will find the whole probability is actually 1. So from 1, if we subtract the large part, we will get smaller part, because in the normal distribution table all the probabilities are more than zero point 0.5. So what we will do, always if we require the smaller part, smaller region, then from whole probability we will subtract the larger region. So it can be written or equal to, here I think we could have written equal symbol instead of or. So let us write equal symbol. So we have explained that from whole probability, from 1, if we subtract the left part p when z is less than 1.255, then that will be our small tiny part. Okay, now using our normal distribution table, you will be given a booklet during the exam. In the booklet there will be normal distribution table. It is, I think, better or more comfortable than using the calculator, because in calculator you will have to change the mode frequently. That's why we are going to use our normal distribution table. Let's see, our z score is 1.255. Okay, 1.2. So first of all, we will find 1.2 in the row 1.2. So this is the row 1.2. Then 5 5, fifth column as well as fifth column. Okay, so for the final fifth column, it is actually 10, and first fifth column is 8749. So it is going to be, sorry, not 8749, it is 8944. 8944. If we add up this, then 9, sorry, this one is also wrongly selected, it will be actually 9. Okay, this is 9. So these are our, this should be added to this. So how did we do? We have first selected the row, then first column as well as the final column. And these two quantities, the marked two quantities should be added. If we add 0.89442 to 0.009, it is going to be 0.8953. It should be, the addition should be like this: 0.8944. Then you are going to add up 0.0009. So surely it is going to be 0.8954 plus 9 is 8953. So that is how we can use the normal distribution table very easily. So our final probability is point, and again I am showing you, look at this. Here the probability starts from zero point 0.5, that means more than half. All the probabilities are, the least probability is half, but that means at the midpoint. Okay, at the midpoint. So if we find any tiny part, for that it's better we find the corresponding probability of the greater part, then we will subtract that part from 1, we will get the tiny part. So for tiny region, we will subtract the greater part from 1. So it is 1 minus 0.89. 1 minus, it is going to be, let me show you whole of the solution together, or or 1 minus 0.8953, 0.89, 0.8953. So finally our probability is going to be 0.105. If we round it up to three significant figures, it is 0.105. So that is what our approximation to this binomial distribution. I think you have understood, as I have clarified every tiny part of this solution. Let's see the immediate next question under the same concept. The next question has been selected from the paper 9709/52 for the session May-June 25. Let's read question number 2 of this paper. It is question number 2. In Milford, 70% of the residents own a bicycle. A random sample of 160 residents is selected. Use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. Let's start our solution as we did in the previous case. First of all, let us write our P. P is 0.70. P is equal to zero point 0.70. So our Q is going to be 0.30. 0.30 is our Q. So let us write X belongs to binomial distribution, and the parameters for binomial distribution is n into np. N is total number of experiment, which is 120. So 120, and our individual probability is 0.70. If we convert it into normal distribution, X belongs to now normal distributions, and for parameters of the normal distribution, we write mean. Mean is NP. Okay, so this is N. Let us write here. This is N and this is P. So parameter for first parameter of normal distribution is mean. Mean is NP. If we multiply 120 by 0.70, it is going to be 160. Sorry, 120. Sorry, our total random sample is 160. So 160 is it is not 120. Instead of that, it is going to be 160. Let me write 160. So our mean is n into p. If we multiply 160 into zero point 0.7, it is going to be 112. So our mean is 112 and our variance is npq. If we multiply, q is 3. If we multiply by zero point 0.3 by 112, it is going to be 33.6. 33.6. Let me write here np and npq. Yes, so we have written the parameters of the normal distribution. Now we are going to find the probability of x is, it is written more than 120, more than 120. So x greater than 120.5. You have not forgotten that we will have to do continuity corrections because it is more than continuity correction. Continuity correction is one of the major parts of such solution. Remember, as it is more than 120, so if we do continuity correction, we will add up zero point 0.5 because it is more than the quantity. After that, if we standardize our score, it is going to be z greater than, you know how to standardize this score. Our x minus mu, I mean mean. Our x is how much? 120.5. 120.5 minus our mean is 112. And standard deviation is the square root of our variance is 33.6. Now using our calculator, we are going to get probability of z greater than, if we use our calculator, it will show 1.466, 1.46 as well as 6. Now we will have to draw a graph to show which part is our actual probability. You know the normal distribution graph is always symmetrical. Here it is 0 and our z score is 1.466 and it is positive. So suppose here it is 1.4. 1.4. Okay, so which part is our probability? This part, greater part, that means on the right side of this z score, because it is written z greater than. Okay, so these tiny parts, if we want to tiny parts as our probability, what we do, from the previous solution you have come to know that just for tiny part we subtract the larger part from whole probability. Whole of the probability is 1, so we can write here that 1 minus probability of z less than, as the left part is larger, so we are going to subtract the larger part. It is 1.466 and you know that none of the probability, corresponding probability in the probability distribution table is less than zero point 0.5. That's why we opt for right part. So we will find the probability when z score is 1.466, then we will subtract that part from 1. Our whole probability is 1 minus, let us see the corresponding probability when z score is 1.466. 1.4, so 1.4 is our row. 1.4 is our row. This is our row 1.4 and then 6. First digit is 6, the second digit is also 6. First of all, we'll have to decide our row. This is our row and column, first column. Then it should be added to another 6. This add should 8 should be added to this. So if we add up this it is 0.9279 plus 8, as I have shown in the previous one, 0.9279. Well, after that we will add up the final digit 0 0 0. The final digit will be added to the final digit, it is 8. So our probability is going to be 0.9287. So you have understood that our probability starts from zero point 0.5, that is none of the probability is little part. If you want to find the little part as probability, you will subtract the greater part and you will get the little part. So we did so. Our probability, the greater part, as we have seen, it is 0.9287. 0.9287. Now if we subtract this greater part, I mean this red part, if we subtract the red part from whole probability, means from 1, then we will get our tiny, that dark part. This part can be subtracted because all the probabilities given in the probability distribution table is more than 5, that means larger part. If you regard the smaller part, always you will find the corresponding probability of the larger part, then you will just subtract. After subtraction we will get 0.0713, 0.071 and 3. That is the answer to this approximation. And I tried my level best to explain every tiny part lying in this solution. Let us see one more solution. The next question has been selected from paper 9709/51 for the session May June 25, and we are going to solve question number 4, which says every Saturday a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation is 2.5 minutes. And question number A and B don't belong to our concept of today. Our topic is different, that is approximation. So let us see question number C. Question number C lies on the next page, which says 80 competitors who took part in this Saturday's event are selected at random. So our N is 80. Use a suitable approximation to find the probability that more than 50 of these competitors had times less than 36.0 minutes. So as usual, we are going to write x belongs to binomial distribution, and for binomial distributions our N is 80, and probability, we are going to write the probability when the competitors had time less than 36 minutes. Okay, so for less than 36 minutes, what is the probability? Let us see from the previous page. It is in question number B. Look, 60% of the competitors, here it is written, 60% of the competitors take time less than 36 minutes. So our probability is 0.60, P is 0.60, Q is 0.40. So let us write this. So our P is 0.60, 0.60 is probability. So P is equal to, let me write with different ink. Our P is equal to zero point 0.6 and our Q is going to be 0.4. And if this is to be converted to binomial, I mean normal distribution, x belongs to normal distribution, and for normal distributions our parameters are mean is n into p. Okay, so this is our n this is and this is our p. So first parameter is mean. If we multiply 80 by zero point 0.6, it is going to be 48. 48, and our second parameter is the variance. Variance is the multiplication of product of NPQ. 48 into zero point 0.4, if it is multiplied, it is going to be 19.2. 19.2 is our variance. This is NP. This first variance, first parameter is NP, and second parameter is N multiplied by P multiplied by Q. Then let's start our solution. Our solution is probability of X. Use a suitable approximation to find the probability that more than 50. Look at this, more than 50. So X is greater than 50 means if we apply continuity correction, then it is going to be 50.5. It is continuity correction. Please don't get confused with this continuity correction. So continuity correction, because it is more than 50, that means if we apply the continuity correction concept, then it is 50.5. Now we are going to standardize the score. Probability of Z greater than 50.5 minus our mean. What is our mean value? Our mean value is 48. 48 over standard deviation. Standard deviation is the square root of variance, which is 19.2. Okay, then using our calculator we are going to get Z greater than, it must be positive, it is going to 50.5 minus 4.8. Z is greater than 0.5705. 0.5705. This is our Z score. Now if we draw a normal distribution graph, then we can be clarified. This is our curve. Okay, so here then the midpoint is 0 and our z score is positive. So suppose it falls over here, zero point 0.5, zero point 0.5 or 0.57 something. So which part is our probability? Our probability is this tiny parts. Okay, this dark part, this black part is our probability, and we know that for tiny probability what we can do, we will find the whole of the probability from which we will subtract the larger part. So this is our larger part. If we subtract this larger part from whole of the graph, whole means one whole probability, the probability of whole region is 1, from 1, if we subtract this red part, left side or red part, then we will get our tiny part. So always whenever we require tiny probability of tiny region, then we will subtract the larger part from 1. Okay, so let us see what is the probability, corresponding probability when z score is 0.5. Before moving on to that, let us write it is from 1 we will subtract the left part. So probability when z is less than 0.5705. Okay, so our z score is 0.5705. Let's see what is the corresponding probability. 0.5705. So first of all, our row is 0.57, I mean 0.5. 0.5. 0.5 is over here. The column is, first row is 0.5. Then 7, first column is 7. So first column is 7. Then the final column is 0.57. Then we require actually 0. Okay, so as there is no 0, so 0.571, it will be 0.57. As it is 0.571, we can take 1. Okay, if we round it up to 3 significant figures, So our probability first, this is the row, this is column, and then we will add up these three. Okay, so if we add up 0.7157, if it is added to 3, so our probability is, corresponding probability is 0.71. 57 plus 3 means 60, so it is 0.716. 0.716 is our corresponding probability. So let us write our corresponding probability for this z score was 0.716. 0.716. After that, if we do subtraction from 1, it is going to be 0.284. 0.284. That is what our approximate value of this normal distribution. And that's how we can solve the question based on approximation from binomial to normal distribution. You can solve this, and I tried my level best to explain every tiny part from each of the questions. And if still there is any confusion and you require that clarification, please let me know through WhatsApp. I will try my level best to remove the complication and difficulty you are facing in solving any of the mechanics one question or probability and statistics one question, and not only mechanic and probability one. It means from paper 1 2 3 4, paper 1 2 3 4 5, any of the papers. If you face any difficulty, please let me know through WhatsApp, and then I will solve that for the benefit of all of the students. Fi amanillah.